Combining two 6.3 filament leads to get 12.6 out. Good evening, YouTube. Back once more. I am here on this same Monday at 7 p.m. in the evening. You can see I have the power transformer in question. I'm going to set up the camera on the scope, and we're going to be using that. What the purpose of this is going to be is I have two 6.3 outputs on this transformer, and what we want to do is combine those to make a 12.6 output. In other words, we'll have a 6.3 at 12.6 and the high voltage output on this panel that we're going to design. So these are the thing here. I've got the scope hooked up to the brown, and the brown yellow I think is what we called that, and I've got the variac hooked up output to the primary. And we're going to energize this, and we're not going to put a lot of voltage on it, just enough to get a good steady pattern on the scope, and find out where our scope pattern, or not our scope pattern, but where our positive and negative pulses are, I guess is what I want to say. And I'm going to use the other trace of the scope to monitor these. And I believe if we put these in phase, we will get 12.6 volts out of the combined total, I should say. In other words, if we get hook it up a certain way and put the negative to the positive, just like a battery, we'll have a series type voltage. I think that's the way it will work, I think. Sometimes these ideas pop in your head and you think, well, this is the way it's got to work, and then you think otherwise when you actually get in there and start testing. So let me get it all hooked up and get a camera set up on the scope, and we will be able to then test our hypothesis. You like that word? Hypothesis. So what I'm going to do is put the probe itself on the solid color of our, I'm just guessing, maybe that's something to do with something. Yeah, I know that doesn't mean nothing that I just said. But what I'm trying to say is I'm guessing maybe if those solid wires are the same, maybe on both things. I don't know what I'm trying to say, really. I haven't even got my scope set up yet for dual trace, AC, dual mono. There we go. Let's move one up a little bit so we can see it. That one's not in the same mode as that one. So trigger level. Alright, now I have the scope set up, but I don't have a camera on it. I want to get this camera set up to where I don't have to actually worry about it. In other words, I don't want to have to I don't want it to be in my way either for me to look at it. So I'm going to try a couple of things here. Let me get that set up, and be right back with you. Alright, there's our... Okay, you can see they are in phase, and that's pretty good. Now I only have 25 volts on it, so I don't really have a lot of current on it. Let me put a little bit more, bring it up a little bit more. It's not coming up a lot, but it is coming up some. I'd like to get several traces on there if I can. There we go. Alright, there's about as best we're going to get it. Now, to prove my point on this, I'm going to switch the probe leads from one to the other, or actually not from one to the other, but in for in, I guess you would say. At 46 volts, I don't know what my output is. I should find out by taking a measurement. So let's see, 20 volts will be fine on that. Give me some. I'll need to switch back to AC again. There we go. And I can just touch this, I think. And I'm not getting anything. There we go. 2.85 volts is what my fluke says. So that is not a lot, but it's enough to... You can see also, I believe, that the trace is not symmetrical on both of those. Move that up a little bit. Move the other one up a hair as well. So there you go. There's what it looks like. Now I'm going to switch these around, and we're going to see exactly if that does switch the, like I think it will, the phase of these. Pretty darn sure it will anyway. Alright, there's one lead connected. And there is the other one. It did not. Interesting. So, that just kind of blew me away. I really thought the phase would switch when I switched the input. But it did not. Anybody care to guess why? Well, for one thing, these are two different windings. In other words, one's on the secondary and one's on the primary. Now, whether that has something to do with it, I don't know. But I'm guessing it does. So, like I said, that is interesting. So I think either one we connect there would give me, I can test that out. I've got my lead connected to that. Let me see if I can get over here and connect to the, whoops, thought I had it connected well, but I don't. I'm going to go from the minus lead to the minus lead, see what that gives us. Okay, that, yeah. Okay, now you can't see this reading, but it went from 2 whatever it was on the output to ouch. No, I see what I'm doing. Don't want to touch that. Just a little spark ain't gonna kill you. Now that says 0.01. I don't think that's right either. Let's try it on the other one and see what that gives us. 282. Alright, there's what I had on the one. Let me try this one again. 282. Now I should be able to get a combined total of 4 something, I think. I'm going to try this. Oop, almost had it. Had 3 something. I seen it for a second. No, that's just 281. Oh, there it is. I got it now. Alright, now I have 5.6. And that is across the 2 scope probes. So that would be from the solid green wire to the banded or striped yellow and brown wire. I get 2.62 volts. So at that point, I am getting 12. I will get 12.6 at the rated output. And I don't want to raise that up, but I'm going to raise it up some and make sure there's nothing else touching. I'll raise that up. We'll have to adjust our scope a little bit, get it back on the screen. Go up one click on both of them. And we did that. And we are on times 10 for both of those now, so there's 9.7. At 100 volts roughly, I have 12.4 on the output now. And you can see everything has stayed the same on the scope, basically. So, basically, like I said, what we're doing is giving ourselves double the voltage. Now, I just got to remember to go from the green to the brown and yellow as our additive type thing, so that that would be our output. We'll just say that would be our output. So if I combine the let's see, how would I do that? Actually, I haven't combined anything. We'd need to combine that to the... I think that's probably what I'm doing wrong. I think I'd need to combine one of those wires with the other ones and take my readings there instead of the other way around. I think once I do that, I'll have what I want. Now, I do have the potential. That's telling me, you know, that I have 12 volts potential between those 2 points. So, you know, it could be hooked up that way. In other words, I could have these outputs not even combined, but if I go from point A to point B, then I'll get 12.6, I think. Let me dip this down just a little so you can see. There is the actual voltage being input to it, 100.76, somewhere around in there. And again, you have the scope over here to the right. And those are the waveforms. So, anybody wants to chime in on this, feel free. I think it's a good idea. I wanted to make sure, though, that it could be done. And like I said, I do get the necessary voltage this way. So that's pretty much all I need to do, I guess. All right, I'm going to call this a success, even though I don't know what I'm doing. Like I say, I'm interested in everybody's comments on this because I know this is done quite often to get even on the circuit board or radio itself. It's often done combining two 6.3 volt sources to get 12.6 for different tube filaments. So interested in how you would say this is working and why it's working this way. Let me back up and show you what I've got here. Now this is the scope negative probe onto the green and white, or green and yellow I should say, lead. This is the scope probe lead from one channel. On the solid green I have my fluke meter hooked up there. On the other side, if we look over here, I have the scope from the other channel hooked on also on this yellow and brown wire, which is a filament wire, and the scope negative probe connection to the solid brown wire. And this is my other lead from the fluke, which again is measuring a little over 12 volts with 99 volts showing on the variac. So like I said, what I'm doing here is I'll make sure you get no power coming, or no well, you can see there's no current being drawn, but like I said, that's how it's set up. And I'll put an illustration of this on the screen and show you that, and that will help out maybe, I don't know. But there you have it. Again, I tried some other. I should be able to move this here and move that there and get the same thing, I think. Let me try that. That gives me 6. That gives me 0. Okay, they cancel each other out there. Now we're getting interesting. I thought there was a way to do that. So at that point, connecting to the two negatives of the scope probe, I get a 0 output. So that does tell a story, I think. Here I get 6 volts if I hook it up here. And that's what I, would be a normal thing. And then if I hook this wire, well, if I didn't mess it up, hook this wire here, which is where it was, and then hook this wire back up here. There I am at 12. Oops, kind of lost it. I just don't have a very good connection on this one here. In fact, I don't have any connection on it. There we go. All right, 12.12. There you go. So there you go. That's the difference. So I'm glad we did this. I'm gonna have to stop and think about all this while I did. All right, you guys have a wonderful, wonderful evening. Again, leave your comments. Let me know where I went wrong or what I did good or whatever. And see what you think. So, guys, have a pleasant evening. Thanks for watching, and we will see ya.